Okay, so unfortunately I had to start over. My last video got interrupted. So I'm just going to talk you through the beginning of this. So I apologize. So we're going to talk about finding the arc length of a piece of a circle. So when we're talking about arc length, there's that piece of the circle, and yes, you have your central angle, which technically, if we were using this as an example, you would say that the arc length for S is 60 degrees. But when we're talking about arc length in this sense, we're talking about it being measured in centimeters, meters, or an actual distance measure. So the formula comes from the circumference formula, which is 2 pi r. And with degrees, it's pretty easy to remember because, you have your entire circle, it's out of 360 degrees. So this piece at 60 degrees out of the whole circle times the circumference is going to give you that fraction of the whole entire circumference. So if we were to solve this problem, you have your 60 degrees out of 360. And arc length, for some reason, is always S. So when you see S, that means your arc length. So S equals 60 out of your 360 times 2 times pi, and your radius is 5. Okay, so 2 times 5 is 10. If we simplify this fraction, that's 1/6 of your circle times 10 pi. We're going to leave all of our answers as exact as possible, and remember, when we do that, we leave pi in our answer. So 10/6 simplifies to 5/3, giving us 5 pi over 3 centimeters. So 5 pi over 3 centimeters. And Ms. Greenberg likes fractions, so we have 5/3 pi centimeters. So that's for our 60-degree angle with a 5 centimeter radius. So then you have your radians. So radians is a little bit of a different formula because, remember, radians is using pi and the radius. So again, we still have that our circumference is 2 pi r. And if you remember, a whole circle is 2 pi. So your arc length is your central angle. This time it's going to be in radians though, out of your whole, which is 2 pi, times your 2 pi r. Now we can simplify this formula, because if we were to multiply this, we would have 2 pi r times theta over 2 pi. So really, we can cancel out our 2 pi, and you're left with your arc length is just your angle measured in radians times your radius. So that's pretty easy. That's like as simple as you can get almost. So this is our central angle. And remember, that's theta. It's like a fancy O. And we simplified. Leaving us with just our central angle times our radius. So when we do our example problem, it's, again, pretty simple. So we have our central angle in radians is pi over 2. So S is our pi over 2 times our radius of 16. And we can label it like that's radians. Right. So if we were to solve this, 16 times pi over 2, which just is 8 pi centimeters. So you're going to have to remember multiplying fractions and your rules for multiplying and simplifying fractions, because you are going to be doing that a lot with this topic. Okay, so let's move on. So if we have, what is the length of an arc of a circle? Our radius is 4. Our central angle is 120 degrees. So we're going to need our degree formula for that, because notice our central angle is in degrees. Okay, so we're going to make a note of that. So our central angle is 120. So if we're looking for our arc length, we take our central angle, so 120, and that's out of 360 times 2 times pi times our radius of 4. Okay, so 120 out of 360, it simplifies to 1/3. So that's 1/3 times 8 pi. All right, well, 8 pi times 1 is just 8 pi. And we keep our 3 centimeters. Okay, so that's just 8 pi over 3 centimeters. Okay, so now we have what is the length of the arc, and it has a radius of 10. Central angle is 4 pi over 5. That should say that that's radians. It should be labeled radians. Okay, so we're going to use our radian formula. And so when we use our radian formula, the arc length is just our angle times our radius. So S is going to equal 4 pi over 5 times 10. Okay, well, 4 times 10 is 40 pi over 5. So 40 divided by 5 gives us our 8 pi centimeters. Oh look, these must be like the same exact circle practically. Just with a different central angle and radius. Okay. So now this one's going to be a little different because it wants the central angle measure. So it says find the measure in radians of the central angle that intercepts an arc length of 4 pi with a radius of 10. Okay, so I'm just going to list our information. So our arc length is 4 pi. We have a radius of 10 centimeters, and then we don't know what our angle measure is, so theta we don't know. Okay, well, so since it says in radians, we're going to go back up to our radian formula. So we know that that's S equals theta times R. So we'll just plug in our formula, our information that we have. So 4 pi equals, we don't know, so we'll just label that X times our radius of 10. And then we're just going to solve this like any other formula. So we're going to divide both sides by 10 because that's how we're going to isolate X. So divide by 10 on both sides. So 4 pi over 10. We can simplify that because 4 and 10 are both an even number. So 2 pi over 5 must be our central angle measure. So theta equals 2 pi over 5 radians. Okay, so we've got some more example problems on the back. Oh. Okay, so if you are like, okay, I'm done listening to you, Ms. Greenberg, I want to try these on my own, then you guys go ahead and try them. And then you can come back and check the end of the video for the answers and see if you're correct. And then if you get one wrong, watch my explanation on it. But if you feel like, okay, I'm still not really 100% positive how to do it, then continue watching and follow along with these couple examples. Alright, so we have a central angle of 30 degrees. So since our angle's in degrees, we're going to use our degree formula. And we have a radius of 3. So what's our arc length? So S equals, our angle measure is 30 out of 360 times 2 times pi times 3. Okay, well 30 out of 360 is 1/12 of the circle, so that's 1/12. 2 times 3 equals 6, so that's 6 pi. Well, 6 and 12 simplify, giving us pi over 2 centimeters. So notice this E next to each answer, that just means your exact answer. So that just means, you know, that's your exact answer, so that means you should have pi in your answer. So we have a central angle of 90 degrees with a radius of 8. So if we were looking for the arc length of that, we're going to use our degree formula because our angle is in degrees. So that means we're doing 90 out of 360. Ooh. And that's times 2 pi 8, because 8 is our radius. So 90 out of 360 is 1/4. And then 2 times 8 is 16 pi. So that's 16 pi over 4. And 16 divided by 4 is 4. So you have 4 pi centimeters. Okay, so now we have a circle here. We have pi over 6 radians, so that's our radian formula. And so that is just our central angle of pi over 6 times our radius of 18. Now 18 divided by 6 is 3, so that's 3 pi centimeters. Alright, 3 more. So we have another radian central angle, so we're going to use our radian formula. So that's pi over 4. We have a radius of 12. So 12 times pi is just 12 pi. 12 divided by 4 is 3. So again, we have 3 pi centimeters. Okay, so 7 pi over 6 radians is our angle. So 7 pi over 6 times our radius of 3. So that's 3 times 7 is 21 times pi over 6. So 21 over 6 simplifies because you can divide them both by 3. So we will have 7 pi over 2 centimeters. All right, last but not least, 72 degrees. So we're going to go back to our degree formula. 10 centimeters is our radius. So 72 degrees out of 360 degrees times our 2 pi times 10. So 10 times 2 is 20. Well, actually, let's see. 72 out of 360. That's actually 1/5 of our circle times 20 pi. So 20 divided by 5 is 4 pi centimeters. Okay, so if you went and did these on your own, I hope you got them all right. Here are your answers. If you didn't, I hope this helped, and I hope when you do go back and you do your problems or do the quick check that you're good to go. If you have any questions, just message me and I will be free to answer.